All right. Welcome to day 3 of CAD-a-thon. The first thing we're going to do is finish the intake assembly. After that, we're going to get into some discussions about how to practically figure out what ratio you need for we're using chains in specific for this example. Just get some practice with that since we did gears on the intake. We're going to practice finding an optimal chain or belt ratio for our shooter angle. But first, we need to finish our intake assembly. So we were nearly done the day before. We just need to add our gears, and then there's a hex shaft we don't have in here. So, is everyone who has the document on this tab? All right. Yep, you can make a copy from where we are. Josh, are you able to get here? Do you want to make a copy so that you're in the same spot? After. Josh, Suhaib, you guys good?
You both have your own documents, and then we have to get shit caught up with this.
You two good?
Yeah.
So,
Okay.
you understand?
You good?
Yeah.
All right. So I'm gonna begin.
He's in a part student. You're in assembly.
Just a little quieter. I'm gonna begin fastening some of these gears. So I'm just gonna grab this one. I believe it's the 36 tooth. We'll see after it highlights up in the top left. To fasten mate it, what you'll do is click this tool up here in the top left. It's this little cylinder with the lower half shaded, or you can click M, and then I'm clicking the center point of this gear, which happens to be the 42 tooth gear instead of the 36 like I thought, but that's okay. So the 42 tooth gear, we can check in our intake parts because I forgot which one that's on. Yep. 42 divided by 20, that tells me the 42 tooth gear with 20 dp is on this bearing here. So going back to our assembly, it canceled my mate, so I'll re-enter it by hitting M or hitting that in the top left. I'm going to hit this center point here, and then I'll go to this bearing and I'll hit the center point on that and move my view, but the hexagons aren't lined up. We can just hit rotate secondary axis once and it gets it lined up. And then I'll hit this check mark instead of the one in the top left to commit this one and start another one right away. So then I'm just going to grab this 20 tooth gear here, hit the center, and then that one is going to be on the hex shaft of our Versaplanetary Neo 550 here. So what I'm going to do for that one is I'm just going to grab the center of this circle here, which will put it right here, and that shows kinda that these gears will be meshing, and we would be able to rotate these to see that they will. I'm gonna hit the same other check mark. I'll grab the center of this 36 tooth gear. My view got messed up, but that's okay. We'll put it on this intake one. It doesn't matter since we have two 36 tooth gear and they're both on the intake wheels. I'll reorient the secondary axis because it was showing an interference. I'm gonna hit the check mark again, grab our last 36 tooth gear, you can see here with all these like lines overlapping here, that's how I could tell that the secondary axis needed reorienting. So when I do that, you can see the hexagon very clearly, and that shows the hex shaft and the hex bore on the gear are not conflicting with each other. So I'm going to commit this. Is everyone here? How do you what? Rotate objects or my view? So since we're fasten-mating it, no, it's okay. Since we're fasten-mating it, we don't need to rotate it. When we select these mate connectors, it will automatically rotate the object. Does that make sense, Sue? All right. You guys ready to do the next step?
You can change.
You need help, you said? All right. How are you, Craig and John?
Let's see. And then other basic principles would be, this is fillet, it rounds the corners that you have selected. It can round entire faces, so it's all the corners that are around the face, or it can round selected corners. And then the one next to it is chamfer, which essentially just makes an angle. And then for you, let's go to next, the three boxes on the plus side. And go for MK.
You let go.
So the one thing I don't like about OnShape is that when you put
Yeah,
it
you
in
sometimes
on
have to
it,
hit click
in
on
my
it.
experience, it has never actually been used.
No.
And it should take you to a setup.
You want it to be on the center there because when we did those construction circles, that was with the idea of the center of the gear goes to that center point. So I think it's on your 42 tooth gear. Is that the one that did offset?
So it's that box right there, and that allows you to
Delete the offset.
most of the commonly used CAD sparks.
So
If you're grabbing the center point of those bearings, it's fine. That's
Yeah.
fine.
It allows you to do
Because
most of the
that's
commonly
not
used and then the
real.
arrows are.
It's our calculation. We know that.
For the sketches mostly work on the plans.
That's because,
And so.
yeah, that's how it is.
That's
how it is on the
final.
I mean, that's why I opted it. As long as they give. I don't do it. So like 45
OnShape is interpretive, which means if you know all the different things about it, it's easier than if you kind of assume one thing does one.
Oh, wait.
So,
I'll get that brief. I think you can do it. So, Surabe, what do you need? You got it? Okay. So, say you grab the wrong point on your gear, right? And you didn't just hit X right away, you confirmed it. And then you look over here and you have like fasten 1 through 16. You don't know how to find it. What we can do is, say this gear is the one that has it wrong. We can right click on the part in this assembly. We can hit show mates. And what that does is it highlights it here on our assembly with this little rectangle. And it's the only one in bold on the side. So then I would be able to click into here. I can change these mate connectors, or I can just delete the fasten mate altogether if I wanted. And then when you're done, you can click on the part again and hit hide mates. Yep.
So the thing about this is that there are two sides. There's one engine that is only two holes, and then there's the other that is all four holes.
You two good?
We're experimenting.
All right.
OnShape's dimensions are mostly.
Are you ready to go on to the next thing?
Get something OnShape knows is parallel.
Okay.
We'll attach a parallel
You're okay.
dimension to it.
Anyway, I can help you.
Thinks it's not parallel. Then we'll try to angle at whatever point it's decided to move it intersect. And then the other thing is.
Yep, I'm just going to give it a little bit of time for everyone to get caught up.
So construction thing is something where it creates a shape but doesn't regard it as like a fill-in shape. So it's essentially optimized, allows to show where something would be without having to interfere with the execution. Otherwise, it gets to be
Thank you, Ron.
the what?
Suhaib, Gabriel, you two ready?
Off of the part, and then right click and
Do you need me to check on you?
could it be middle mouse?
Wait, so
that one
Missile mouse button. I don't have that button.
Yeah, right there.
I just zoom in and out frantically. Helps me research it, but whether you want to do that or not depends on how much patience you have. So neither of you have. So we use a lot of. We have a very long list of tools that we use at this point to include all of our different things. With the most you have to send in MKCAD, which is essentially all the parts we use. And then it gets more specific with stuff like mounting pool generator and other things.
What?
And then
Oh, wait,
those are typically two parts on top of each other. If you want the parts to not be on top of each
So that one can go on the
you
intake
can
field.
go down, do
The
a little
36
four blocks,
particular.
click that arrow to drop down.
You tell it
And
to find. It feels so much more complicated than coding.
It's this one, click the transform.
All right,
I mean, technically coding,
I'm-
right?
Transform.
I'm gonna go on to the locking collars, and then after we finish the intake,
Or you can hit that.
we'll do another pause. So we have our locking collars here, and we can fasten mate those again, going to the same spot to use the fasten mate tool. And going on our locking collar, the furthest out point, if we go on this arc so that it's highlighting right here on the locking collar, so it's highlighting this. We want to hit the center point while that's highlighted because that will give us the furthest out point of our locking collar. If it's highlighting another point like this, what you can do is hold shift while it's doing that. That will keep the same mates available or visible. And then you can move your mouse. While still holding shift, you'll left click it. Hopefully, it'll pop up. So we've selected that one. And then for this one, I'm just gonna put it. All these will go like on top of the gears to keep them from going out. So I'm gonna grab the center point on the outside of this gear, and I'll put it there. That's bad. We don't want it to intersect. What we can do is flip the primary axis, and then we can see the hex shaft is interfering with it, so we can rotate the secondary axis, and then boom. That did it, and we can see that there's no interference here with the locking collar in the gear. So I'm going to grab the second check mark to commit it and start another one. And I'm just going to do the same type of thing with all the locking collars on top of all the gears.
If you want to delete a part, you can probably just click the part in the part select and just delete it. Otherwise, if you delete line by line, and then
Oh, I should have just deleted so that's one.
Create a new file for the part.
yeah.
So
And then I like using rectangles because these are all rectangles. But we have to select one of the rectangle tools so it might be blocked.
Oh, right, I forgot about that. And then that needs to be 50 by 50.
It will stay blue until you make it so it cannot move around. The easiest way to do that is to attach one of the corners to the little dot that should be working.
Great, how do we do that?
Go back in the sketch.
Alright, does everyone know how to get all the locking collars on? Okay, I'm just going to give a little bit of time to do it. Raise your hand if you need any help.
It makes those 2 points overlap. And it's attached to it somehow.
J. Douglas, don't distract them. Don't distract the kids.
I cannot distract you.
And then
We have
actually,
50 by
this is a
50 by
good
10.
is that you can actually put sketches on top of other
Yep.
pieces. So if you have to do this,
Sketch, let's select that. And then what was the undo button again? I made 2
so hover over that just so that I can see what the keybind is. I can use it, but it's okay, you deselected the rectangle. Now you can just highlight all of that. You have to highlight that part. Now you can constrain that to corners.
Alright, well, let's imagine it first.
Actually 20 by 10. So they're actually going to 20 by 20.
Wait, is it? Once again, this.
To that corner of. Actually, wait. This is not going to be the most friendly shape. How long? 2 hours? Okay.
You don't have to ask me for permission to get water.
Change that to 10. We can make it one side. I don't know which part.
He's supposed to
So change that. Change the vertical dimension to 10. And they just would you? Oh, that's where the key to extrude. See, sometimes I just forget things because I don't use them. He's wearing that.
Alright. Hey, Suhaib, have you finished the locking collars?
Everything was orange, you dropped out of the sketch. If you want another sketch, you're going to sketch.
How are you doing, John?
That's what we can tell what the next
And then we
is.
can go back.
Oh, nice. I know that's an option, but I'm just used to OnShape, so I'd stick to that. Yeah. I do think it's nice how you can change the controls to if you're used to something else.
So 20. Let's see. This will be 20.
So are you done?
25. And then extrude 10.
Yeah.
Tab might work.
Okay.
Like, just decide you can go in here and change the color.
I'm gonna start the next thing. Suhaib, I trust you to keep up. Okay, so on this 42 tooth gear here, right now all these parts are floating in space because we don't actually have a hex shaft here. If we tried building it as is right now, it would just fall apart. That's not good. So, before we didn't necessarily know how wide or how long our hex shaft would have to be until we added all these parts into our assembly. So, now that we have these parts in assembly, we can figure out the length from one end to the other. So, I'm going to grab the circle that's the outside of this hex bearing here. And then I'm going to grab the arc here on this locking collar, because that's the outermost point. So that selects a circle and an arc that have the same center, just different along the Z direction. So you can see here it's telling me the center distance. We can hit the measure details to see that the center distance is all in the Z direction, meaning that those centers are overlapping, just like how we wanted it to be. What we can do, I'm going to click on this Z measurement, which will highlight it all for me. We can see that the 3.11 it was showing is actually 1.310500. I'm going to copy that, and then I'll hit the X on that measure detail, and then going back to intake COTS and going to our part studio. What we can do is go to CAD. I have it favorited, but in case you don't, we can do 1/2 quotation mark, and under extrusions and shafts, which is the second heading, we can see 1/2 inch hex shaft configurable. And for the effective length, I'll select all of it, hitting Control A, and then I'll paste in that measurement we have. Profile, 1/2 inch thunder hex, that's fine. I'm going to change the retention to bolt and washer for both sides. And include and merge is fine for what we're doing. This length is what we got from our assembly. It's the distance from the outside of our hex bearing to the outside of that hex collar, and it's 1.31050. It's what? It's the 1/2 quotation mark hex shaft, and it's under extrusions and shafts in CAD. So I did that so you know what to type in. Because 1/2 inch you could do like 0.5. And then we can see it inserted this shaft object. I have all my parts overlapping, so I just went down here and found this. And I'm going to change the tessellation quality by hitting Edit Appearance, Tessellation Quality, and I'm going to make that coarse. And then I'll do check mark. And then we can go back to our intake assembly. Go to insert. Under intake COTS, we can go here. We do have two shafts. Since we just put it in, you'll probably see generating preview. That's the one we're going to want to grab. If we didn't know the length of either, since they're different names, we could rename it. We probably should. But if the preview was there, we'd be able to see it was shorter. And then I'm going to hit check to keep that part there. I'm going to fasten mate this to the outside of that arc we grabbed. And then I'll hit check mark. And we can see it goes right to the outside. Yep. Yep. To get the tessellation, we can go to that part studio. And it's the bottommost object since it's the last one we added. We can right click on it. And then the fourth from the top, edit appearance. That opens this little menu. And then the Are you in the part studio? Yep. Are you going to the bottom part here instead of here? Are you going here? Yep. Yep.
So this is
deterministic.
So,
This is entirely constrained because it cannot move in any
how much time does everyone need to get to have this finished intake? Are we all good?
A couple days.
Besides you two, I know you guys. Ryan's helping you.
We're in day 2.
Nice.
Okay. This is the spiel for ratios. We use gears.
You do good?
It's all beautiful.
Yeah,
Are you here? Do you have a finished assembly? Alright. Get it into the what?
That would be unfortunate.
Alright. To insert that hex shaft, we can go to insert in the top left. Go to the intake COTS. We just click down on that. And it's this bottom shaft. I'm going to change the name to include the length for all of these. If you have one that says generating preview, it'll be that one. That's interesting. I would recommend changing the name. 18.5. 18.4375. So, just for clarity, I'm going to this part studio. I'm changing the name of shaft to 18.4375 inch hex shaft. And then for shaft, I'm going to rename it as well. And that was 1.3105 inch hex shaft. And then by renaming it, if you still haven't inserted the parts, that makes it a little clearer.
And then we attach them to gears that are supposed to hold up a 4-foot long arm on a half-inch hex shaft on the smallest motor. It was one of the smallest motors we had.
On the smallest motor.
I could bring the arm down. The motor's only burnt out a couple different times.
For clarity, Ryan or I didn't make it.
For clarity, I didn't make it either.
Yeah, I said Ryan or I.
It was a decision made based
All right.
on constraints.
Is everyone here? Does everyone have this intake assembly?
And
Oh, where the shaft goes? I got you. Okay, So when you insert it, it'll be floating off in space here, right? We can hit our fasten mate. We'll click one of these. That is, it's showing us a mate connector. We'll just grab that. We'll go to the outside of this locking collar, and we'll grab the center point of it. If it's pointing into the intake, we'll hit flip primary axis, and then we're gonna hit check mark. And then to hide those mate connectors, I just hit K on my computer. You want it to you want the hex shaft to go into the gear and into the bearing. You don't want it to just be floating off in space.
You get close to an average of 1:4 ratio mechanical advantage for screws. Yeah, for 1 pound of force you put on turning the screw, you get 24 pounds of force with thread weight. And it changes depending on how the screw.
You configured your hex shaft wrong. So,
Several hundred.
Per inch? There would be.
No.
You might honestly break the threads without you anything.
We can double click on the derived half-inch hex shaft here on the bottom. If you did configure it wrong, or like have a wrong length, we can change the effective length here. We can change the profile, but for the retention, which I think was your problem, Josh, we want bolt and washer on both sides and include and merge everything for the S1 and S2.
I'm assuming this one is main shut off. So
Is that what the problem was, Josh? Yeah, for S1, bolt and washer, S2, bolt and washer, include and merge everything for both, so that your settings match this. Hey, lock in.
We are locking in. We're locking in. Sending the cannon. T-shirt cannon. T-shirt cannon.
That's not very relevant.
It's very relevant. We're learning computer design in terms of T-shirt cannons.
Pneumatics.
All right. We all good? So the next thing, we can go to the top-down configurable folder here, and CAD-a-thon starting document. We can see now, if you have all these mate connectors, I'm just going to hit K, because that gets messy. And we have this that is just floating around in space. So, we're going to put that on the robot where it belongs. This was decided before by our team. This is just copying the placement. So I'm going to grab one of the inner bolt holes on one of the plates. So this is on the, sorry, I'm trying to remember what side this is. That's on the right side.
Sorry.
Yeah.
And we'll take that bolt hole, and it's not the first top one here, it's this one. And we're going to flip primary axis so it's facing the right way, and then reorient secondary axis so that it sits in there nicely. And then I'll hit the check mark, and boom, we have our intake fully CAD'd and in our assembly. Does everyone know how to get to this point, or is at this point? Yep.
Sorry, I missed the part where you. How did you navigate the drive base?
Yep. So we were in the intake folder before in WIP intake. So I just went on this bottom tab here and went to top-down configurable drive base, right next to the home icon in the bottom left. I clicked on that, and then I clicked on the CAD-a-thon starting document, and that takes you to the right place. Okay, I thought I forgot to start recording. I didn't. You too good? Do you know how to get good?
I know how. I don't think
Oh, that's fine.
that is.
So, I'll explain. So if you hit solve, that shows you what happens after you hit the click. So you can use that to kind of judge. So we can see that we need to hit the, yep, that's good. Don't hit cancel. You're doing good. So then you would reorient the secondary axis. The circle one, yeah, just spin it. And then you hit check. Oh, you did it too many times.
Oh, I'm supposed to do it.
Yeah. Okay, so we can go back. So hit the X. Scroll down here. It would be your wax fasten. Double click on that part at and we can just hit the circle there. Yeah, 3 times. Hit the check.
But it's
Oh. Is mine flipping? Is that you? Let me double check.
They come right and click the wrong thing.
Yeah. You grabbed a wrong mate along the way.
No, it's not supposed to be there.
You can try and go through your intake to fix it. Right now it's not a huge deal. We know that these dimensions are right. And we can see that this Neo 550 here looks like it's going to hit, but it doesn't. And we can check this by hitting our Neo 550. We can start clicking a bunch of things to try and see the interference. And we can grab this protractor in the bottom right. If we hover over it, it says Show Analysis Tools. You can click that, interference detection. And normally we'd see like it highlighting bright red. It says we have an interference here, but that's not an us problem. That's from the simplified Mark IV-I. Since it simplifies the design, it shows an interference that doesn't actually exist. But we can see we don't have any interferences that are on our end. Okay. Are you 3 good here? Are you good? Okay. Yeah, so you're going to need to edit that. That's me. Is that the one you did?
I could have made it these spaces.
Oh. That's the wrong thing to parallel. Because I get your thought process, but that's the top of it.
Okay. Everything is now made.
Okay. So you can drag your intake up to make it more visible. Yeah.
Yes. Yeah. Yes.
I like to think about it with like how are you going to fit the realities instead of like doing this parallelly. So grab like where one of the screw bolts is going to be. It doesn't really matter. Just one of them. On the inside probably, because these go on the outside of those aluminum. For your fastening. Yep, me grab it, sorry. Yep. So that's the top right. So that's going to be over here on that one. And it's the 6th hole. Yeah, you can grab an easy one. And it'll be on this space. Yeah. And then you're gonna reorient the secondary axis using the little. Yep. And then you can hit the boom.
It seems like you are.
This looks good.
Yeah, I got it.
What's floating in space? Is that from the intake assembly? Why do you have so much floating in space? Why is it all like that?
Wait.
Hit the K. Yeah.
I have stuff floating in space too.
There's nothing floating.
Oh,
What do I do to
it's stuff that you didn't make. In your intake.
I really did that.
What?
No.
We don't need it.
There's a couple of them.
Okay,
So since I just
Yeah, you're probably grab one of the inside faces of your intake
It's
plate.
floating in space.
That's the outside space.
Bro, it's going to be made
The
in
grand majority of things are.
No, there's just a lot of
Yeah, then that one's nice because it's floating down. That's our
They're actually not floating in any
No,
way.
But,
we personally call them that.
It will
Oh,
be
not
the
that
second
small, because they're no longer. Like, we call it.
entire space.
Oh no, they're no longer.
That one. Yep.
Nope.
Yeah, but no.
And
Exactly.
then you're gonna reorient this.
I also want to
These
say
are not safe.
Oh yeah, you're primary. But those are your
Keep moving, moving, huh?
and then you'll reorient secondary stuff.
I'm talking, okay, we call up Russia, you know. That's the hey.
2 more times.
No, I'm talking about. Okay, we're talking about that.
Oh.
Let's not talk about that check mark.
No,
We're
talking.
The top
we're talking
defensive
Russia.
wall
I'll
we're
say,
gonna make.
yo, Russia was good. Oh yeah, how we use it so.
Okay, zoom out.
You know,
On
to go
your
to
second
like
layer.
Why aren't you using launch some debris to space? That's what we do.
What do you have that's not? Start dragging your hands on those corners.
No, but we use
Drag your gears.
to go to
The brown.
Yes, we have.
You're telling me, you woke up last.
No, I
I found the problem. You need to make that gear to that pair here. That's probably the only problem you have. Escape out of it here, because it'll be a little hard. We can drag that
I
out
guess things.
Okay,
So that we can grab that, make better. and then do it.
Oh,
I don't know,
just drag it out so it's
more
easier. Did you fix your stuff floating in space, Gabriel?
Yeah.
He did. He just ignored it.
No, it's not there anymore.
Did you hide it?
No.
What did you do to get rid of it?
Alt F4.
No. Oh. Go here, assembly your intake assembly.
Where is that?
Under the intake folder,
Okay.
on the bottom,
Oh,
Wait, is this correct?
your intake assembly. WIP intake.
Wait, so.
Why are those? Just delete those. Your other wheels are fine.
Wait, so.
Oh,
He had the rest of the assembly. You just had extra parts.
so what if so what if it's
No,
okay?
Okay, that's a different gear.
Oh, no,
So go back to your assembly.
Okay.
He's never been there.
Yeah. Wrong thing. That's not for the cut. So go back to your intake return folder. WIP intake. So you see the small gear on top of the orange shaft.
Yeah.
Drag that away. So you can fascinate it better. Okay. Then make that the
Hey, so I spread I would do. I said over here.
Where are you going?
So I spread I would do. Did he not respond?
Yeah, why did you respond to that?
Because that's his name.
The name's Ashton, actually.
The name is what you call somebody to get their attention. If I tell you I would say spread you.
try and make it. I wasn't watching. I checked the
Name,
slide.
then, a word or set of words by which a person, item, place, or thing is known as a short person.
I call you mumbo jumbo.
Yeah. That would be a word I am known
If I call
as
you-
or refer to.
I call you word, good.
I promise you it's not gonna happen because never in your
And then we're gonna put that.
When have you told somebody, I'm only gonna call you this for the rest of the time, it's gonna be really fun, and it's happened more than like a weekend.
No. So go to the line
I have.
that is on
To
the
this day, I
like
still call my
Or
friend
the
Mason
little-
Lucid.
yeah, that
You call
like
me
that.
Mason Lucid?
Put
I
that.
call him Lucid.
Why do you call me Lucid?
Yeah,
Because
click it
in
and tell
seventh grade.
That's good.
Because
Use the X. Your third next one. Boom. Your intake should be fine.
And now the actual problem.
Okay. Do you know how to make it so that it's good? Like
What?
you don't have to do that because you don't have any primary or secondary axes till you start selecting make connectors. So
What did you do to get rid of your primary and secondary axes?
So you're gonna want to grab one of the inside faces of your intake plate, probably near the front. So Zoom in a little bit more. Rotate so you can see the top right hole of that one. Yeah, cool. Grab that top right one. Okay, zoom out. And that will go.
You can also refer to it as a position. So
You're moving around a lot,
so
Siri.
that's a
Go so
position.
that we
Stop. Nope.
Don't go on that second
Well,
one.
that's
From the top. No, on this space.
Yep.
Yeah. Not just like one, not the top one. Separate from
Lots
the.
of languages are that big, right? Because
So-
one of them this is
Yeah, that one.
years.
It's hard to explain.
Yes,
I'm
was a
sure.
robot.
Oh, no.
Okay.
Our dictionary.
Flip your primary
So
axis.
dictionaries, boom, or you know,
Rotate your secondary either once or 3 times. We'll see.
so the definition changes.
3 times total.
The definition, yeah. This
And
is.
check mark.
using it in the same way.
Hit the X.
Refer to me as-
Oh, just show
Boom. You have an intake. We all have an intake. Let's go. So, are you two good?
I'm good with except one thing, and I can have you fill me in afterwards.
All right. I'm going to share the slideshow now. So, we're going to be. You two are good, right? Yeah. You guys were talking concern. So, we're going to be covering chain design because that's what our end goal here is that shooter bed. To move the angle for this, we're going to use chains. So we want to know how to CAD them. So where you want to use it is like when you have like high torque on like massive arms or like a heavy shooter bed, something like that, and something that's going to be moving a lot. How to design this, you'll want to know your input and output sprocket locations. So like the center point of your big sprocket and the center point of your smaller one. You'll want to determine the sprockets based off the ratio. We'll go over how to do that and adjust for specifics, so just making that center size right in CAD. Ryan made this slide. I don't know what it's saying. Tension chain. Oh, yeah. So this is stuff that you'll have to do when you actually have it. So routing it using idlers, so that'd be like adding a third sprocket in there to like properly like route it. When you like have it on the robot, you'll want some way to tension the chain, so make it tighter so that your chain isn't loose on there, because then that could slip out like when your chain falls off on a bicycle. We don't want that. And then the design center points based on calculated centers. We'll go over that, but we just grab that straight from a calculator. So this is what we're going to be making. So we'll calculate how to get these sprockets, but we're going to be making the intake plates here, importing these motors, and this is what our shooter bed will connect to in order to angle it. That's all I have for this right now. So, can you guys on the Meet see my camera? Can I pin that to make it more visible? For myself, or not for myself. Pin it for everyone. Oh. Okay. What? Unpin the other one. You're so right. Oh, I'm drawing on it. I think I can stop presenting. Okay. So, actually, one more thing before we go to the whiteboard. So, on OnShape, we have this shooter bed assembly that was so generously provided to us. And so, we're going to be rotating it at this triangle here. That's where the hex shaft will go through. It's a triangle because it's easier to mill out, but it functions the same as if we had a hexagon there. but we want to know the distance from the center of this like triangle that's circumscribed around a circle. We want to know the center distance of that to the outside of here, because we're going to be calculating the torque around that point. And for torque, that's going to be it's force around a radius. The force in this case is gravity, and what we're going to be assuming is that it's a point mass at the furthest point from there. This and this will let us have an excess in torque, so we don't have to worry about our motors burning out from not producing enough torque to move the shooter bed. So, just in advance, our shooter bed weighs around 15 pounds. That's a known. So then from the center here, can I grab the center of this triangle or no? No clue. I'm just going to grab it from here, and then we can do some stuff with the length. So I'm going to grab, I'm stuck on this right face here using the cube. I'm looking directly on the right side, and then I just click this line on this tube. And what I'm doing is I'm trying to find the length from this line to the edge of our shooter plate, or shooter bed. So then we can see which one sticks out further. I think they're the same radius, actually. So we can go here. In the show measure details, we're going to be wanting to look at this max distance number, and specifically in the y direction, because if we look in the top right, we can see that z is our up and down, which is not super relevant to the torque that we're calculating, but y is going to be that distance. So we can see in the y direction, it's 17.763824. I'm going to write that on the board now. Programmers aren't using this anymore. Do we have an eraser? Seven, 6, 3, 8, 2, 4. Inches. So that's our length from the edge of that to there. But we didn't grab it from the center, like where we're going to be rotating around. So that length is kind of wrong. So what we can do to get the actual is we can go to shooter bed parts. This is just a part studio where all the parts are coming from. And I'm trying to find what sketch represents this. Okay, it's sketch 3. This is where our triangle is made and then extruded into this plate. And we can see, yeah, we know that these circles on our tube have a center distance of 0.5 from that edge, and we have this triangle, it's concentric with that circle, meaning it shares the same center. So we know it's 0.5, so our distance here is going to be that minus 0.5. 2. All right. Is that all we need to do in OnShape? I think so. So, stop presenting. All right. So, this is the distance here, and we know that torque is going to be equal to R times F, which F in this case is just going to be our pounds, because pounds is a force of gravity. So we have 17.26 ... times, we said 15 pounds. What does that equal, Josh? Use this number.
times 15.
Yeah.
258. 258. 0.957. 957. 375.
Boom.
375.
It is. Okay. So our unit for torque in this case, we have inches times pounds for our distance times force. Our distance is inches. Our force is in pounds. So our unit is going to be inch pounds of torque. So that's how much torque is going to be produced by our shooter bed in inch pounds. That's what we use in FRC. So then the next step, we know it's going to be driven by the motor we chose for this is 2775 Pros. And effectively, what that does is on either side, we can consider half of the torque. So, Josh, what's this number divided by 2?
That's going to be 129.47.
Oh, it's in reverse for them. I feel bad.
8688.
What?
8688.
So, this is the torque we're going to want to match or be greater than on either side. And in reality, if we're a little bit under, it's fine because we assumed it's a point mass on the very end. So this is a higher amount of torque than is actually produced. What? I know it's backwards. I can't do anything.
Use the camera.
What?
Use the camera.
What camera on the back? I'm not writing it in reverse. So our motor of choice is a what?
150.
I don't know what you're saying. So the motor we're using is a motor called the 775 Pro. I'm going to start sharing my screen again. So we can go to Vex Robotics here. Or I'll look up 775 Pro Vex. And then we can see this. So this is the motor we're using. And so under here, we can see details, kit contents, docs, drawing, weight, and it's under other info is what we want. So then we can see the stall torque. This is what we're going to be using in our calculation. And we can see, what?
Gears.
It's 6.28 inch-pounds of torque is what our motor produces. So I'm going to write 6.28 times, man, I'm switching markers. 6.28 times, I'm going to put G for gear ratio. And I'm simplifying this to 130. So another thing we know for this is we're going to be using a versaplanetary. So what that's going to do is it'll multiply our 6.28 by a static amount. And then we'll have our gear ratio here. That's going to be our larger sprocket divided by our smaller sprocket in terms of number of teeth. So I'm going to expand it out a bit more. So it's 6.28. And I'll do times V times, I'll do, what do I want to do? I'll do big D for driven and small d, for a driver. And we have that equals 130. This is an equation we can really solve. So first we want to pick some values. And the easiest thing to pick would be our versaplanetary here. So generally we want to stick below the high gear ratio versaplanetaries, or else those will start stripping out. That's just a fact type of thing. So I'm going to choose 5. So 6.28 times 5 equals d over d. Not equals times equals 130. Okay, so Josh, what does 6.28 times 5 equal?
31.4.
31.4. What is 130 divided by 31.4?
4.123.
4.123? All right. Really?
I'm still using the 129.
Okay. That's fine. Equals, what was it?
4.123. It just sounds like a fake example number.
It does.
But it isn't.
Okay. So we want our gear ratio to be roughly like equal to or greater than that. So the next step, I'm going to go to Recalc, which is a chain calculator. To go to that, you can just look up Recalc. It should be the first thing that pops up. If it isn't, the URL is reca .lc. And what we want to look at is our chain calculator. We're going to be using a number 35 chain here, just because if it were on our shooter bed, it'd be dealing with high load, and this gives us access to some bigger sprockets. So this then kind of just shows us some sprockets available. It doesn't show all of them, sadly. So I'm going to start typing some stuff in. So the desired center, I'm going to say that's roughly 12 inches. So that this tells us if we had a 16-tooth gear and a 36-tooth gear, we'd have these different options to get close to that center distance. But obviously, it'd be 36 divided by 16. That doesn't equal 4. So we want to look at two chains that or two sprockets that when you divide their teeth, it'll be roughly equal to 4. So nice thing we can do here is we can go to West Coast Products, where we get a lot of our stuff. We can go to belts, chains, and gears, number 35 sprockets, and then boom, it gives us all our options, really. So we can just kind of see what's available to us. So if we had an 18-tooth sprocket here, we could do something that's roughly 4 times as great as that. So that'd be 72. Hey, that's an option. These spline XL plates, sprockets, they're a little suckier to deal with just because we're used to dealing with hex shafts. So I'm going to see if there's any other options for 18 tooth with half-inch hex bore. And there is. Boom. So we'll end up using this 18 tooth and this 72 tooth. And that'll give us roughly 4 for our gear ratio. Or that is 4. And then when we multiply it by the torque our motor produces and the versaplanetary, that gives us a nice solid foundation. So Josh, I'm going to ask you to do some more math. We have 6.28, and I'll simplify it times 20. What does that equal?
125.6.
125.6?
Mm-hmm.
And while this isn't equal to our 129, that's fine, because this is a very high estimate of our torque.
Where's our 20 from?
5 from our versaplanetary,
Okay.
and then our gear ratio from our sprockets is 4, because 72 divided by 18 equals 4. Boom. So this should be fine. So we can go back to recalc and still the desired center of 20. Or not 20, 12. I just put that in there because I know 72 tooth sprocket is pretty big. And I knew that's what we were using beforehand. And then we can do 18, 72. And that gives us two center distances that we can use in our design. We'll see what looks better as we do it, because what we'll end up doing is we're not going to make this 12-inch long plate. We'll have two separate plates on either side. So 4 plates total. 2 of them are identical. And one will have the 72 tooth gear, and one will have the 18 tooth gear in our motor. And that's what we'll use. So the 12-inch, when we're looking at the center distance, we want to make sure that our bolt holes to put these plates on line up. And we'll see how that looks when we start CADing the parts. But we have a solid foundation to begin CADing. Would everyone agree? Does this make sense to everyone? All right. Don't show that again. So, in this top-down configurable folder, you have a shooter angle folder. So these are just things that we already have. So we know that our hex shaft is going to have to spin however much. So I just put that in for you. And we'll have hex bearings again. But we're going to need to make some new parts. So we'll go to this plus right beside the house in the bottom left. And we'll hit Create Part Studio. And Part Studio 4 isn't descriptive. So I'm going to change that to Shooter Angle Parts. Okay. How can we start for this? Any ideas?
Making a square.
That's not bad. MKCAD, that's not a terrible idea, but this part studio right now, we're not in the CAD studio. What we're doing is we're making the parts that we'd machine or manufacture ourselves. So we don't need to put our imported parts in here. So we can start making a square by hitting Sketch. It's kind of subjective what plane you start on. I'm a big fan of starting on the top plane. What? This is the XY plane. So, a square, not a bad start. I'm going to start by making this square. I'm going to use a corner rectangle instead. And I'm just going to arbitrarily drag these out for now. And what I'm actually going to end up doing, I'm going to delete this horizontal constraint and this parallel constraint. I'm going to delete all these, actually on the top, all these constraints. This line is going to end up being a construction line because we don't want our sprocket sticking straight up from our mounting area because we want it to be kind of somewhat closer to our intake so that it meshes. So if we hover over this line, we can see it gives us 3 boxes, this 90-degree, parallel, and horizontal. If we click on one of these boxes and then hit backspace or delete, it'll delete it, and we can just do that for all 3. And then it still has them coincided. So that's great. The next thing we're going to want to do is this plate, we're going to eventually mount to the robot. So we want to make those mounting holes. Does anyone have a suggestion for how we can start that?
Make a hole.
Yeah. We can start with just one, and then we can linear pattern this. So I'll start with one hole. I'm just going to drag it out while that gray box is still around it. I'm going to type in 0.196 for a 1032 hole. If that box went away for you, no biggie. What we can do, I'm just going to take the measurement. We can hit D, or we can go up to the top for the dimension tool. It has a little number line, kind of. And then we can just click on our circle, the outside, click off of it, and type in our dimension. So, nothing right now. This rectangle is going to be constrained. The lengths do have like a nice round number, but we're just going to base it off of the mounting holes. Yes, Greg?
Why don't you start with the mountain holes?
Why didn't I?
Rectangle.
You could have. I don't know. It doesn't matter a whole lot.
Can I throw a
Yeah.
suggestion? So typically when you do a sketch, you want to put the important stuff at the origin.
Yeah.
Okay, so in this case, the axis of one of your holes, maybe what you want in the origin, and set up your hole positions, and then when you're all done putting your holes in, then draw your rectangle around.
All right.
Just
I support this idea.
throwing it out, sorry.
No, you're all good. I don't know. I don't do like CAD super formally. So I'm gonna delete this rectangle based off what Greg said.
Sorry.
Greg is completely in the right. So the origin, this is where we're gonna put our important stuff, like he said, and this mounting hole is pretty important, I'd say. So I'm just gonna use the coincide tool up here at the top. You can also hit I. I'm gonna hit the center of the circle, and I'm gonna put that right there. Does everyone have a circle at the origin? Do you need help, Zach?
Yes, please.
All right. Oh, you exited your sketch. So you're gonna need to re-enter that so you can edit it. Yep. We're only gonna hit the check for the X. We'll hit the X if we mess up and we want to undo everything. The check, that's for when we're completely done. And we're not completely done yet.
Not yet.
So the next thing, we're gonna mount it with just 4 holes here. So since it's in a square pattern, something we can use is a linear pattern. So I'm gonna hit the linear pattern tool. It's up here at the top, next to all these. It gives you 4 squares. One of them is in this darker gray, and then you have 3 blue squares. You'll hit that, and then you can hit your circle. And we'll change this 1 to a 2 to give us 2 rows. And we'll change this 3 to a 2 to give us 2 columns. And then if we hit confirm, we have our mounting holes in a perfect square pattern, and they're fully constrained, as you can see, so these can't move around. Everyone good on this? How can I help you, Zach?
Don't know.
Let me.
There. What? Oh,
So
yeah.
mine, when I highlighted, change the 1 to 2, so that they all, it doesn't let you do it.
Yep. When you do your linear pattern and you have it like this, you have to double click on it like you're editing a file. And then you change that to a 2, and you change the 3 to a 2 in the same way.
Thank you.
Yep. In OnShape, if you want to edit something, you always just double click into it. Do you have this square, Zach?
Working on it.
Yep. Let me know if you need any help. Okay. Does he not have it? Okay. So the next important thing would be where we're putting the sprocket. For now, we can just put a hole for our sprocket, and we'll dimension it to other stuff later. So this sprocket is going to have a bearing mount. So we'll do, for the dimension of this circle, we'll do 1.125 or 1 1/8. That's tragic. Do you have a charger? You have a MacBook, right? Yes. All right. Does everyone have this bearing hole? Whose computer isn't dead? You have it, Zach? Or do you need help? All right. Zuhaib, Gabriel, you too good? All right. So the next thing, I kind of just decided these when I was making the parts for the curriculum. They weren't super thought out because I was kind of rushing in this part. But I'm going to put this circle where our center of the sprocket is. I'm going to make that vertical to our rightmost mounting holes. And what that does, instead of having it center in between our mounting holes, it'll shift it a little bit towards the intake so that our shooter bed, the note from the intake feeds right into it. So I'll click V for vertical, or you can go in the top right, you'll have a drop down by this coincide, and you'll hit the vertical line. I'm going to hit the center point of that circle and the center point of one of these mounting holes here on the right, and that snaps it here to the mounting hole. Then the next thing is we're going to dimension it vertically on the y-axis here from this mounting hole, and this measurement is actually took directly from what we have on the robot that we know works for our vertical dimension, and that is 2 7/8 or 2.875. And now I'd argue we have our most critical geometry. We can also add something for our sprocket here for how the pitch diameter when we have the chain, which will come in handy later. So is that on recalc? That's without the chain. So something we can do here then is if we go to, I'm going to go to the 70, I'm on the West Coast product page for these sprockets that we're going to use. And we're using a 72 tooth aluminum plate sprocket. And I'm going to hit the drawing on this. And then the outer diameter with chain is what we want here for how much space the sprocket's going to take up with the chain. So that's the 8.948 inches. So we can go back to our CAD, make a construction circle by hitting our circle tool in the top left, and then this construction, or you can hit C and then Q. And I'm going to make this construction circle coincide with the center of our bearing hole, because our sprocket will be right on that. And I'll just click off of it. While it still gives me that gray box to edit the dimension, I'll put 8.948.
Is that the right number?
Yes,
You said a 72 tooth sprocket?
72 tooth sprocket with a number 35 chain. So yeah, that's straight from the product page. It's a little big. That's why the center distance is 12. The 72 sprocket takes up a lot of space. So we have our critical geometry, we have our mounting hole, and we have where our sprocket's going to go. So then we can start designing the plate around it. So first we can start with a corner rectangle, and I'm going to just put it in the bottom right next to these mounting holes. I'm going to make sure it's not a construction rectangle, and I'm going to go like that just to click off of it so that this rectangle fully encases our mounting holes. And the same thing as before, I'm going to delete these constraints here because this vertical line or this horizontal line at the top isn't going to end up being, or I think that was because of how I did it before. I don't know, we can just leave it like that. So the next thing is, for our plates, what we like to do is have the center distance on either side of our mounting holes be 0.5. So I'm going to distance from the outside wall here on our rightmost mounting hole to the rightmost wall. I'm going to make that 0.5. I'll do the same right here. And then we can do the same to the top. And we can do the same to the left. And that'll give us a fully constrained rectangle. Maybe. A square, same thing.
Say again those dimensions.
Yep, 0.5 from the center of our mounting holes to either side. So from the bottom, 0.5, from the right, 0.5, from the left, 0.5, and from the top, 0.5.
Well, why not instead do 0.5 from the outermost side of the circle? If your mounting hole is like an inch, and has like a radius of 1 inch, then the 0.5.
So they don't have a radius of 1 inch. They have a radius of 0.196. The 0.5, the 0.5 on the sides isn't as important, but from the top and bottom, this is because with the tube we're mounting this on, the holes we're going to be sticking it on, those are 0.5 inches from the bottom of that and from the top of that. So those are the most important. On the side, we can really do anything. The 0.5 is kind of just for symmetry. What?
It's not 1 inch though.
What do you mean? All right. So on this mounting plate for the sprocket, right now we just have a bearing hole floating in space. We need something to go around that. So I'm just going to make a 3-point arc. And I'm going to click the first point on the top left here of our rectangle / square that we made. And then for the second point, I'm going to hit right here on the second point right there. And then I'm just going to drag it out so it encases our bearing hole. What?
That's just freestyle.
At first. Okay. Is everyone here? I haven't checked up in a while. Do you need help, Zach? Do you want me to show you how to dimension or something? Okay. I'm gonna give a little bit of time for Zuhaib and Gabriel. All right. Even earlier than last time. Wow.
I showed up. That's why we had to be on my CAD for today.
All right. Everyone good to move on? Are you fine if we move on, Zach?
Yeah.
Okay. The next thing I'm going to do, and why we ended up deleting the constraints of that top line, is I'm going to coincide the center of this 3-point arc with the center of our sprocket hole here. So I clicked I, or you can hit the coincide tool, and then I'm going to click the center point of our arc and the center point of our circle, and that causes it to lean a little. Deleting all those constraints kind of messed up a lot of it. So what we can do to remedy this is we can use the vertical constraint, and we can hit our 2 side points like that, or just one actually. They're constrained to be parallel. I forgot about that. And I'm going to make that top line a construction line so that when we extrude this plate, it's all nice and dandy. I coincided the center point of the arc with the center point of this bearing hole. Do you two need help? I bet you didn't delete the constraints. Is it red?
Yes, everything is red. Where's the delete straight button?
Okay. You deleted the dimension. So the distance from this construction line for our linear pattern needs to be 1 inch. Oh, when you were dragging it, not that. It escaped.
I
The construction line.
I did not do that.
The top two. The top two. Like that one. The vertical one is. You need to dimension that.
That didn't work very well.
And make that one.
Okay.
I'll fix it all. I don't know what else is wrong with yours. Oh, then coincide these 3 points. I. And click that. Like that. Okay. Then make that one vertical that are right in this false. Yep.
How will I make it?
Try dragging some of your stuff around. That will see
Yes,
what's
that.
wrong with it. Without pulling the actual. Okay. Okay, that's interesting. Okay, stop dragging it around. Command C. Okay, so click B to describe all tools. B. I just have all these dimensions. I'm not going to try and feel as fast as possible. So I want you to click the construction line. That way you can mention feed 1 inch here. So that one right here. And that left wall of that plate.
I think it's because it tried to put a point on those.
Okay, and do the same for the bottom.
Delete one of those. Not like that. That one will probably work. So just delete that.
Boom! It's fixed.
Okay, apparently that's not
Okay. Yep.
Everything is screened in.
I know it's not.
What?
So see this?
That is
Yes. Yeah.
Oh, the same with the
those
other.
are.
Yeah.
I think.
Yeah.
So it's those are constraints, and when it's red, it's showing you that it's over a constraint.
I don't
Meaning
think
you have
that.
too many dimensions that conflict with each other.
You have to first
So,
install the instructions to deal with.
That's what I was gonna do.
Like that.
Oh.
By old logic, this should be physical, but it's not.
Go down this line.
Yes.
Oh, I'm just going to take control for a
We have
Why
to
is
do
it
that.
not because I have this also something much
Also because I wanted to watch this.
And then if it's on best. If it does.
Really? Because I'm not a suffering.
Never mind.
Ryan, you want to do some troubleshooting for me? This thing is fully over constrained. I don't know what's wrong with it.
Hey Keith, you want to try?
Yeah.
Why? Okay, so let's see. The one that John had was
Yep, we're all right.
where the constraint is to something.
Where's the window cool? Okay. That's that for your ring for it. That's that. Okay. Are you helping Ashton?
How much do you want the bearing hole to be vertical to the top?
Why is that very?
You want it to be vertical to the top
Yes.
of that hole?
Yeah.
More than
That's what
one
I
percent of
said.
the thing.
Both can be true. That's what I had.
It can't all be true.
That's what I had. Both are true in mine. You want me to prove?
I'm looking at it, Keaton. It can't both be vertical to the mount hole and be centered with the plate. It can be centered with the arc.
Oh, it's not. It's centered with the arc, not the plate. Why do you have it centered with the No, but that means you're not meshing the intake.
From the moment I understood the weakness of my flesh, I had to refresh this tab so that it goes.
Are you guys good enough to move on? Suhaib, Gabriel, Ashen, Jay, Dougie?
I had never seen it do
Yeah.
that.
No, I could pause.
Okay.
We're experiencing new, undiscovered bugs.
Okay, there we go. Okay, it constrained itself strangely.
I
Oh, okay, you had vertically constrained the whole.
I'm gonna pause till everyone gets to this point.
Yes, but you made it line up against both of them simultaneously.
Bro, I have never seen you do that. Achievement from me too.
Okay, what's the dimension? 2.875?
Yeah.
It's backwards, but it'll come.
Make that line vertical.
I wouldn't even call it.
Just like me.
Oh, I saw it.
Yeah.
It's lying to you.
I'm not.
Yes.
Okay, so.
So that top line shouldn't be horizontal. Right now it's treating it horizontal.
Wonders of me.
Looks like it's.
All you
There's, what's the dimension of the inner circle?
The inner circle, it's a bearing hole, 1.125.
Okay, what's the larger?
I am doing sure.
It's the radius of that larger arc isn't defined.
Is
It's just based off the other constraints.
which other constraint do we?
So the arc coincides with the top left of that rectangle and the top right.
Okay, how tall is that rectangle supposed to be? Oh wait, no, I see it.
You good?
Just wait. There we go.
Sam.
No, that did not do the thing I was expecting.
Okay.
You just delete all the point
That's
five
right,
dimensions
right
and
side,
delete them.
upside down.
It makes things like.
Yeah, I'm actually doing the same thing right now because the 0.5 dimension is from a not vertical line.
Literally know that I got a new high score as Juliet and Justin.
I sure do. Oh, okay.
I did. New high school.
Okay.
Because I'm like I'm actually her. So it's totally not wrong.
Is everyone almost ready or ready?
We're trying.
Yep.
Yep.
Ryan, are you fine if I move on?
Yeah, we should be.
Okay. So we can click confirm on this sketch, and I'm going to extrude it, and these plates are going to be 1/4 of an inch thick so that they fully house our bearing holes. We can see looking at this plate, there's no like cutouts in it. It's gonna weigh a little bit.
There we go. Just we'll use that, and if we need to make it even bigger, we will.
So
I'm trying to sketch.
I would say we want to have some cutouts. Yeah?
I think we should put it in a circle.
Oh, like the large arc? Yeah, I agree, J Dougie. So I'm going. You can do this a lot of different ways. Yeah, wait, yeah, Josh, you can lead how we're gonna do these cutouts.
I think we should do an offset from the two arcs.
What do you mean by an offset?
I think it's O. There's an offset tool somewhere.
There is an offset tool. I haven't used this.
I don't know where to
It is. Oh, you were right. It's like a weird lumpy thing.
Oh, wait, offset. Yeah.
Okay.
Use offset tool on this outside arc.
Yeah.
And let's say we want 1/4 of an inch of material, maybe.
So we do 1/4 inch on the other side.
Yeah.
So this offset tool, I haven't used it before, but if we hit it on our arc, it's going to make another arc that on all sides of it, it's 1/4 of an inch offset from it. Okay. Are we good to confirm this one, Josh?
I think so.
So this doesn't create a cutout. What can we do?
I think we need to connect the ends at the bottom of the arc.
Okay. Coincident constraint can't be added to 2 points from the same curve.
Like a line.
Oh, okay. So we can just add a line here. This won't be a construction line, and we'll just connect the 2 points on the bottom here. Josh, it's not fully constrained. What do you want to do?
Offset it from the construction line.
Okay.
When I say offset, I mean like dimension.
Okay. What should our dimension be, Josh?
0.25 again.
Okay. So this doesn't create a cutout. What can we do? Because
I think we need to make another offset on the middle part and then extrude that center section.
all right. So you're saying
We can offset from the center circle as well.
how much do you reckon?
Screw it. 0.25 again.
Okay.
And I think we'd be able to now only extrude the part outside of. Wait. Now it's floating in space.
Yeah.
Just connect a little bit.
So
What can we do to make it not float in space, Josh? Do you want me to give a suggestion?
I'd like to hear a suggestion from you.
Well, we can only cut out certain parts. So what we could do is we can start adding lines that go like towards our center circle. I'm actually going to delete this offset you have.
Yeah, I think maybe connect like the endpoints of the arc to the center circle.
I think we need a little bit more than that because we're going to have a whole shooter bed
Oh.
resting on this. But I don't think you have a bad idea. Do you mind if I do it in a different way? Your ideas aren't bad. I'm going to delete this. I'm going to make a circle that is on the same center point. And I'm just going to drag it out. And we can use Josh's dimensions here. And I'm going to do 0.25. So, it's pretty similar to what Josh did, but this allows it to be like a uniform circle in our cutouts. And then we're going to need to add a second circle here. And I'm going to dimension it to our other one, and I'm going to make that 0.5. So right now, if we tried extruding this, if we skip one of these circles, no matter what, we're going to have something floating in space. That's not good. So what we can do is we can start adding lines here from our circle to one of the others. So we can like use our line tool, hit it on this circle, and go to this one. And then we can do the same here. So in this case, what we'd be doing is either once we have enough of them, we'd skip extruding one of these. I forgot what they're called, what these shapes are called. We'd skip extruding one of these. One of the macaronis.
They're called circle segments.
Circle segments.
They look like pipe.
Yep. We just skip extruding one of these. I'm going to go with having 4 segments around all sides here, just to keep it nice. And right now, we'll leave these not dimensioned. We'll do that later.
Keegan, how do you keep those lines perpendicular? How do you keep them radial rather than being on angles?
What do you mean?
The lines, how do you pick them so that they stay perpendicular to the circle itself?
I'm just making a line and then having it coincide on the circle, and then I just drag it to another one.
Doesn't look like they are.
They're not like perpendicular to anything. They're just coinciding with 2 points right now. Yep. Eventually we're gonna have them be like perpendicular. Like you said. Yep. But not right now. We're just gonna add these sketch elements at first. That's how I prefer to CAD, but you could make a segment, add your constraints, make another segment, add your constraints. But I prefer to make all the sketch elements and then do all the constraints at once. It's just preference. You're so right, Josh. We could.
You could do circular pattern and then
Yeah.
take the center point, pattern it around.
Yep.
You know, evenly space them.
Are you guys fine if we do something a little more complicated like a radial pattern?
I think that's good, because then we can change it if we want, like maybe 5 sections instead of 4.
I agree. We can delete these lines. And we're gonna, it kind of simplifies it and kind of makes it a little more complicated. Where we got our linear pattern before, like when we were making the mounting holes, if we hit the drop down next to it, the little arrow, we can see circular pattern. And then the first thing you're gonna click is what you want to have a circular pattern, which are gonna be these 2 lines. And what that does is it's gonna spawn a circle here, a construction circle, around the center, or around the origin, and we can just drag this box that has our circular pattern, and we can put it on this center point. And the radius should already, or the diameter should be good enough that it's overlapping with the one circle we wanted to do. So, and then instead times 3, I'm going to do times 4. Okay. Okay, what did you miss? Okay, I'm going to Control Z it. So, you'll have linear pattern here, Zach, in the top on your toolbox. And you'll click the drop down right next to it, and you'll hit circular pattern, because we're going around a circle. And then the first thing you're going to want to hit are the sketch entities we're doing this pattern for. Ashton, do you have to leave?
Soon.
Alright. So we're going to do these 2 lines. And then what it'll do is it makes this little circle, and it starts doing a circular pattern around the origin. We can grab this rectangle, though, and we can drag it to the center of the circle we already have. And then we can double click the X3 to make that X4. And then we can click to confirm it. Yep. All right, everyone here? Let's start constraining these, because right now they're kind of, they're not constrained. They're not like that, like vertical, it's not nice.
An issue with these types of constraints is that it won't take the center as a constraint unless you make it coincide.
So, what I'm gonna do to start trying to achieve this is I'm gonna horizontal these 2 dots and these 2, and that'll cause it to essentially be vertical. This segment, this little pie segment, points straight into there, and I don't know how to describe it. What? So I horizontaled these 2 right here that are around that circle, and then these 2. And then it looks like what we don't have constrained right now is the angle between these 2 lines. I'm going to choose 60. An angle measure of 60 here. What that's going to do is the angle between what we're not cutting out here. How sure are you?
I don't know. I'd rather do 40.
You want to do 45?
Yeah.
Suhaib,
Well, that makes sense.
you need help? All right. If you need help helping him, let me know. I'm just going to do 60. So, I'm not sure what's not defined right now. And so what we can do is we can start dragging our undefined elements to see what's causing them to be not fully constrained. And we can see that while the angle is static, we can change the distance between our points. They're already all equal. Huh, what did I do? Yeah, probably. Does this already exist? Yeah. Okay. I know what we can do. I'm going to make a construction line here, just between these 2 points. And then I'm going to dimension it. And this is somewhat arbitrary. I'm going to do 0.5, just because it's nice and round. And then we have a lot going on here. Frankly, a lot of these sketch elements aren't necessary to what we'll be extruding. So we can use something, I think it's called the snip tool. I forgot what it's called. Oh, trim. Yep, it's scissors. You can hit M for it. And what we'll be doing is we're trimming, not all that. Yeah, we're trimming the stuff in between here. All we're going to cut out are these 4 segments here. So we can delete the lines that don't help us define that. So we can delete this arc, and this arc, this arc, this arc, this arc, and this arc.
Everything's on fire. That's like I'm trying to hold as best I can.
Usually-
Goes red,
Usually once it turns red, I just hit the undo button and try and not try to figure out why.
Well, what are you here?
Let's see, I guess, how many steps before did you run into this? Okay, so.
You could.
This,
I decided because I was
Horizontal.
I believe
Horizontal.
Yeah, that one. You can select these 2 lines, or like
These two?
not lines, sorry, the points on the lines that connect to the center circle, and you want to do it on the same 5 segment, like that.
So this.
Nope, this and that.
It's supposed to be 60.
1 second.
Don't change it to
Wait 1 second. Control R. That did not work out.
Yeah.
Circle.
How did I what?
How do you select only?
Oh, right.
Let me control Z it. Okay, to select only that arc, I have the trim tool selected. You need to have that beforehand. Do you have the trim tool selected? It's on the top. It's little scissors. And then you hover over the arc you want to delete. Yep. But it doesn't, you can't select only the arcs unless you have that trim tool selected. Just because yeah, it'll select the entire circle if you don't have the trim tool selected beforehand.
Draw a line.
Okay. I think I'm grasping the concept.
Okay.
Good time with that.
All right.
Thank you. Sorry for
Yep.
leaving early once again.
You're
I
okay.
think tomorrow I'm free.
I've just been messing with you. You're all good.
I know, but just for your.
We're just gonna leave that block there.
All right. I need to help Suhaib.
As someone who sat next to Josh this entire time, bro, he's not.
Overconstrain this part. That's your issue.
Josh.
Let's make a circle big again.
Josh, you lost for the
Let's
construction.
make
Thanks, Keegan.
I can tell you why it's not working.
concentric.
mine first.
Yeah.
I can make it.
No idea what
I don't know how to fix concentric entirely.
Hit escape.
Yeah.
So what's your line?
My suggestion is that the next time it
Then
turns
hit you.
red, undo immediately. Because otherwise diagnostics get painful.
Do I need a line between these? Okay, I just real cats.
I will listen to your suggestions.
OnShape is also built
That
on
was
What?
Just because you use Inventor doesn't mean that OnShape is working.
Wait, what's
Make that.
what's different?
Inventor is entirely computer-based, which means it depends entirely on how good your computer is.
So
And also how good you are, but also the file management system
confused by
is
the
slightly
dimensions?
different. Okay.
Why do you
So hey, you
Keegan,
can change
what?
Yeah.
I don't know. I unfortunately was probably not paying attention enough for this to make sense.
Just change the 45 to 60. It doesn't really matter. I started with circles, and those lines,
I'm gonna start with arcs.
those lines are on the circle instead of on the. Actually, I think it achieves the same
I
thing.
saw this kid in
It's-
hella massive.
It does. It's just I thought about it differently, but it takes a
So essentially,
I must check your stuff.
I don't know what the space things are here,
Um,
but
I
okay,
think
we're
Josh
looking for
messed
60-degree arcs.
0.25.
I think Josh messed up somewhere.
Yeah, Josh is an up.
Okay,
Yeah, because we have.
we're looking for another point.
This kid reminds me of This kid reminds me of
Yes.
That looks slightly
Okay,
wrong,
change
but
it.
I'm gonna
And
go
then
with
4 of them with no attachment to the center.
And I'm going
All right.
to go.
I'm gonna confirm the sketch. That extrude then got messed up because it's selecting things that we don't want.
Okay, and then, yeah,
So what we can then do is select these segments here, and then we have our cutouts, quarter inch from that outside, and then I forgot what that dimension is, but this gives us our cutouts, and we have one solid part that's 25 inches through. Are you ready to do the extrude, Gabriel?
Yes, I am ready.
I'm changing one of Joshua's dimensions because I don't like it. The 0.25, I'm changing that to 0.5. It doesn't matter that much. I don't know, it felt too close to the outside, especially with having our shooter bed resting on this plate. I'm going to quickly go to Edit Appearance. I'm going to make it gray and make the tessellation quality coarse. I'm going to rename it. I'm going to name it 72 Tooth Sprocket Plate.
Now the added bonus is that this is usable enough that you can go in here and change the
Sprocket plate. That's what our chains, they go on sprockets. It's like a gear for chains.
0.5, which means you can change the size of the
Do we have any-
radioactive isotope.
What?
Thank you.
What you should be teaching this class?
All right. You have this part now, Zach? Yeah. I just changed one of Josh's dimensions. That's why ours look different. But one thing I did do that you haven't done yet is down here in the bottom leftish, for you it'll say part 1 here. We're gonna right click on that, go to edit appearance. We're going to make it the second gray from the left because that's just our team standard for our metal aluminum cutout parts we have. And then tessellation qualities course.
Alright, so we don't need it to be super precise, we just need it to be precise-ish.
The tessellation quality doesn't change what's actually represented. It just makes it load faster. It changes the display that you're seeing, but for like the code that represents this part, it's still perfect circles.
Perfect circles. With an ability to the degree of accuracy.
I'd say they're pretty accurate since they're just using code to represent that and using the actual variable pi. Okay. How are you two doing? What is Josh doing?
This is what happens when you say following along without me. Okay, so I tried to horizontal these 2 points. I horizontal. And it's actually back here.
He doesn't have a metal part.
The best folks are having straight hair such style for me backwards. One of these points is actually on circle.
Let's go.
How short are you? Really good. I'm very short because look at this.
You're very shit about
These lines are 2 separate lines.
Okay. Then make one of them actually on the circle if one isn't.
Every second.
I'm going further.
Did you?
I'm leaving Zuhid behind. Alright. So,
Nicely sandwiched. Everything easily accessible relatively.
alright, Gabriel, Zach. I'm going to rename our sketch 1 because we're going to have multiple parts here. I'm going to rename it to the same thing our part's named actually, 72th sprocket plate. And we can differentiate that it's not a part because there's a little pencil next to it. So we know it's a sketch. So just right click on your sketch and then rename should be the first option. The same thing that we named our part. 72T for tooth, sprocket plate. Alright. Does everyone have this part? Does Suhaib have this part, Josh? Yeah. All you have to do is change the experience.
That's not.
Josh is doing the right stuff right now.
Yeah, but didn't you like change it back to 0.5? No.
Josh, you're selecting wrong things. Josh, sit in your seat.
Josh, you're selling. You're selling.
Why is it making multiple parts? Something's up with your sketch where they aren't coinciding with each other.
Everything is on fire and we
No,
don't know
that's
why.
it.
We know why. It's because of Josh.
It's because of Josh.
Josh, how did you do this?
Okay.
Why were you mad?
Why are you listening to it?
Why you hated me too, don't you?
Alright. Change the name of your part as well to match. Alright. We're gonna start another sketch for our second sprocket plate. So I'll hit the sketch tool to make a new sketch, and I'm going to hit the top plane as well so that I can interact with the 72 tooth sprocket. And I'm actually going to hide the part so I just see the sketch. So, similar to how we started with the other one, I'm going to start with our mounting holes. And you can go to where it'll automatically make them horizontal. And if you don't, that's okay. What you would just do is hit the horizontal constraint, and then we can hit the horizontal constraint to the origin, and that'll have our holes centered. They'll be horizontal with each other. Okay. So then the next thing we want to do is make another square of our mounting holes. So I'm going to use the linear pattern. I'm going to click our circle, change that 1 times to 2, and change that 3 times to 2 as well.
So we want to make another plate with another circle and another rings and another everything.
Yep, this
Can you just mirror it?
no, because this plate, well, yeah, we could mirror it. We don't know right now. We're gonna define the center distance from the mounting holes after we define the center distance between our sprockets. So we don't know where that mirror line would lie. That's why right now they're just floating in space. What?
What's the diameter you wanted again?
0.196. Does that check out? I can't read your face sometime.
The practice trait. Either 1.6 or 169, and then we kind of use it interchangeably. So we can just drill them out once we have it.
And we want this horizontal.
I know they're not the same thing.
0.16.
I can't remember which one's a 1032 and which one's wrong.
Yeah.
196 is slightly over the 1032 hole because the 1032 volt is actually 1.87.
Linear pattern.
Okay, so it's essentially a loose 1032.
And our CNC doesn't make it perfect.
That's why we have the drill bits.
Wildcard Robotics. We have to drop off tonight. Thank you. We will be back tomorrow. See you later, Wildcard.
Yep, we'll see you tomorrow. Thanks.
Yep. Yep. Have a good night.
You too.
All right. Does everyone have this? Yeah. What's up with?
I should not have done that.
Do you have the square of circles, Zach?
I did think about that. Let me click.
Redo it. I trust you. The next thing we're going to add is our bearing hole. Since we're going to use the motor mount generator that we use on our intake. All right. I'll repeat. Focus facts. I'm going to make a construction circle to represent this bearing hole. That's because we're going to use the same thing we use on our intake for the motor mount generator because we're mounting another versaplanetary. So it's a very similar thing. But we'll add a construction circle with diameter 1.125. And then I'm going to go to our number 35 sprockets. We're grabbing the 18 tooth aluminum double hub sprocket. I'm going to go to the drawings PDF. And we can see I'm going to look specifically at aluminum. I don't think the dimensions change, but the outer diameter with chain is going to be 2.502. So, going back to OnShape, we can make another construction circle around this one with, I think it was 2.502. I'm going to double check that I remembered that right. I did.
With diameter 2.502.
Yep. Do we have this?
Yes.
All right. So, the next most important thing for how we're going to do this is the center distance between these two sprockets. If we go back to our chain calculator, we can see we have two things to pick from here. I'm going to pick the this first one with 110 chain links. So I'm just going to hover over it and copy it, but it's 11.7456. I'm going to go back to OnShape, and I'm going to make a construction line from the center of this circle to the center of our other circle, and then I will do 11.7456, I think it was. Let me check that again. Yep, 11.7456. I'll click into the dimension so that you can see that.
$11.7456.
You two good? Does Suhaib have this?
He's missing the red. And then we want the line.
Oh, so this line is from the center point of this construction circle, or these construction circles that represent our second sprocket, to the center point of the other sprocket. Because we know that from our chain calculator that we want our centers to be this far apart.
How far do we want our four set of circles? How far is the line between the edge of the circle and the middle of the circle on the not the distance between the two sprockets, but on the same thing?
Are you talking about like here to like with this stuff?
Yeah, that stuff over there.
We'll get there once I know they're ready. But that is kind of the next step. Yes? Oh, your linear pattern's not going with it?
Yeah.
That's fine.
Yeah,
That's
we're
fine.
gonna do that next.
Because those dots aren't constrained to our sprocket right now, so they won't move. 11.7456. Are Suhaib and Gabriel good to move on? I want to get this plate done tonight, and then we'll go on to the next stuff for tomorrow. So the next thing is dimensioning these four to the other one, and we know that we want it to be an integer amount of inches, because on the tube we're mounting this to, our holes are 1 inch apart, so we want it to be just a multiple of 1, or we don't want it to be some weird decimal. So I'm going to plug in 11. That looks a little bit too much. This is a little bit of guess and check to try and have it right on, right next to our sprocket, because these holes are going to be on the same plate that our sprocket's mounted to.
Oh, you can just drag it.
I did 10. To show you the process, I did 11 at first, because that was just a guess of how far it would have to be pushed off to the side to line up nicely with our sprocket, and then I did 10. that's why Josh was trying to take you through that process.
Oh, right, that's why everything's off, because it's, I did my thing on the wrong side, so this needs to be more like open-ish.
All right, we ready to do some next steps? Okay. I'm gonna next do the rectangle for our mounting holes. So I'm just gonna drag from one of the corners to the opposite. And then, similar to the other one, I'm going to dimension 0.5 on either side. Or all sides. Another thing we can do, instead of dimensioning all four sides like we did on the other one, what I did here is I added a midpoint to our construction lines from the linear pattern, and those will automatically be fully constrained. And then I add it to the corresponding sides of this rectangle, and then I made these two vertical and these two horizontal, and that allowed me to only dimension two sides, because these two horizontal and then vertical makes it centered. You end up with the same result either way. What's going on?
We got this grass out.
Hmm?
I said we're cooking.
Okay. Are we ready to add an arc? Okay.
I'm ready.
I'm gonna hit A for our 3-point arc, or it's right next to the circle tool. You might have to go in the drop down. And similar to the last one, I'll go on the top left of this rectangle to the top right, and I'm just gonna drag it out. Kind of arbitrarily at first, because we'll dimension everything later.
I don't want it to be one. All right, why are you making a circle?
Make sure you're using the arc tool, not the circle tool.
Center point arc. All right, that's why everything is confusing.
Yep. We're using the 3-point arc. So first you select the two endpoints of the arc, and then you select the midpoint. Yeah. Okay. So the next thing I'm gonna do right now, this bearing hole is like, if we had it right here and we cut it out, it wouldn't work because that's punching like straight through the aluminum plate, or it's like on the aluminum plate. So what I'm going to do, I'm going to grab the horizontal tool, and I'm going to make the center point of our sprocket and the center point of the arc horizontal. That, for me, that shrunk the arc, but we can see that by, yep, to make it so that when we like drag these points, they're horizontal to each other like this. But for me, that shrunk the arc down like this. All right. To get this bearing hole like away from our mounting area, I'm going to dimension it from this line here to the center of either one of these. It doesn't matter. You want to make sure that your dimension is vertical. It's snapping to all different ways for me, but make sure it's vertical. And I'm going to do 1.5.
The center to
The center of one of them, it doesn't matter because they're horizontal. And then to this line from our rectangle.
center to the line from the rectangle, and we want to set that to
1.5. Yep. All right. We all good here? Does Josh have this for you yet, Suhaib?
Yeah, I got it.
I don't trust it. As a final step for this sketch, I'm going to make that top line a construction line. This will just make the extrusion easier. Then I'll hit confirm.
and then green checkbox.
Yep, green checkbox. I'm going to rename this sketch to 18 tooth sprocket plate. Do you two need help? Suhaib? Horizontal to it, and then do the same steps. Yep, 18T sprocket plate. We have 8 minutes left, Josh. Hurry this up. You have this.
Yes.
Is that true, Gabriel?
Yes, that is true.
Okay. We'll confirm that sketch. And we're going to extrude the sketch now. And we'll do the same depth, so 0.25 inches. And make sure it's solid and add, but that should be the default. And we'll just hit check. So now we have this. I'm going to make the sketch visible for our next step by hovering over it and then hitting the eye here. I'm going to rename it to 18T sprocket plate, and I'm going to change the tessellation quality to coarse. We good on this?
Yes, we are.
All right. The next thing we're going to do is our motor mounting feature script. So Zach doesn't have this feature script. So all the motor mounting. Did you set him up with feature scripts?
Yeah.
Oh, okay. You have this then. So in the top right, still on this toolbar, this like last thing, we'll hit the drop down because you'll probably have multiple, and we'll hit motor mounting. Does everyone have this?
Yes.
All right, we'll hit that. For the origin, that'll be the first thing it asks for. We're gonna hit the center here. Hole sizing, VersaPlanetary, that's good. Override boss size 1.125, that's good. Number of holes 2. I'll do 45 degrees for this. And for angle reference, I'm going to click this construction line on our sketch here. And for the merge scope, I'm going to make that the 18 tooth sprocket plate.
Was it 1.125 or
1.125.
Great, that's giving me an error.
What error?
Enter
Oh.
a value between -1 and 1. Current value is 1.125.
For what one is that?
For boss diameter. I got it.
Okay.
Was I doing the wrong thing? Wait, look over right cross sides. Yes. Over
All right.
cross sides. Never mind.
And if you've hit your merge scope and it's still red like this and not showing you the cutouts, all we have to do is flip the extrude that's right next to our merge scope, and that should pop out with our versaplanetary mounting holes. And we can hit the check mark to confirm it. Is everyone on this?
Yes.
Okay. For those of us who 45 degree. For those of us who are here, do we have the chain generator feature script? All right. That's the thing we're going to use next. So we'll hit chain generator. For the tooth 1 count, 18 is right. I'm seeing a message. Oh, stay and go. Sprocket 2 tooth count, we'll make that 72. Pitch, for number 35 chain, it's not 0.35, it's 0.375. And the center to center distance, I'm gonna hit in place, but skip that for now. Oh wait, never mind. Don't skip that for now. We're gonna hit the center hole of where our sprocket will be. Wait, did I do something wrong here? Yeah, my motor mounting is on the wrong thing. I've deceived you all. Did I? No. Sorry. I got confused because these points were like on the same. I did it right. So if you followed along with me, you would have also done it right. But for points, I'm going to hit the center point, the same one we did for our motor mounting. And then I'm going to go over to our other one. For you, you'll probably have the part visible. You'll want to make sure that the sketch is visible, and we want to hit the center point of that. And then it generates a chain, and we can see that it perfectly follows this circle we've added for both of them. So that achieves what we wanted it to. And we can hit check. And now we have our chain, our plates, and yeah. Does everyone have the 2 plates and the chain? All right. You have this, Zach? Do you need help? All.
I do not have a chain tool.
All right. So.
I don't think I have chain tool.
Let me see if I can find it fast. Do you know how to help him import that?
I bet you do.
So, which chain tool are you using?
Chain generator. It's from the same document. Mount generators from.
Fair enough.
I'm going to take you
I
to
can
OnShape
OnShape.com/FRC.
or FRC.com.
Or
And then go to CAD library.
is it that?
I forgot what I used my own version.
Does not exist.
I find that hard to believe.
Fallout Boy.
The same thing.
It's the
though.
same thing. So we'll go here.
What's from back?
Add custom
That's
features.
crazy.
Control
I do it with
that link. Julius features. Go here. Chain path.
Yeah.
Click that, and now you have the chain.
And
I'll rewalk through those steps.
Close that. And
All right. Going back through how to generate a chain, we'll hit our chain generator feature script. 18 tooth for sprocket 1, 72 for sprocket 2. For our pitch, it'll be 0.375 or 3/8, and we'll hit in place to make that true. For the points, we'll do the center point of our 18 tooth sprocket first, and then our center point of our 72 tooth sprocket next. And the offset, that doesn't really matter since we're dealing in the part studio.
100 inches.
I mean, make it so you can still see the chain, but leaving it at its default of 1 is fine. So, does everyone have 2 plates? The 72 tooth sprocket one has our cutouts for weight reduction. Our 18 tooth one just has the motor mount. And then we have our 110 links 35 chain. You two good? All right. We'll call that good for tonight then.
Now we close everything. If you want to, using some usage of task manager.